Hi everyone. So we want to solve the question 88, merge sorted array. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So the final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a len of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a len of n. Here we have some example. In example 1, nums1 and nums2 has the same non-zero value, and we can see that the output is same as nums1, but the len of output is same as nums1, but it has more value that are not 0 than nums1. So what is the solution for this question? So as I said before, for every question, try to bring the brute force approach at the first step. And here the brute force approach is, we can add nums2 to nums1 here, and then try to, and then use the sorted function, the sort function in our language, and sort the total nums1. So here, for example, is 2, 5, and 6. If we add nums2 to nums1, and then we can sort this nums1 here. So let to write this, and it's easy to write. So, and we can say nums1 sort, and we don't need to return anything, since here we sort the nums1 in place, and the output should be nums1. But the problem with this solution is that its time complexity is O of m plus n, since the len of the nums1 is m plus n, and times log m plus n, since we use sort function here. And also space complexity is same, is O of m plus n. It's depend on the language that you're using, but overall, in worst case, consider O of m plus n. So what is the optimal approach for this question? So the optimal approach for this question is using the different pointer for each nums, and try to compare the value at each pointer, and then put the value that are greater or smaller than the other value in the right location. Okay, so here is example 1, and we want to go with this example. The way that we can solve is, we can use 3 different pointers here, and we set our pointer at the last value in our matrix, in our array. So here is, I put one pointer p2 here, one pointer p1 here, and one pointer to write the correct value into nums1. So since nums1 and nums2 are sorted, we compare 3 with 6, and the value that is greater will be the last value. So we change this to 6, and then we decrease this pointer 2 to the previous one. So p2 decreases here, and then we compare 3 with 5, and we put 5 here. So we need one pointer at end of this nums1. So let's write pw here, and let's start from scratch here. So we have p2 here. Okay, so we start to compare, and we compare the value at p3 with value at p2. So we can say, okay, compare these two to each other, and we can see that 6 is greater than 3. We put 6 here. We decrease this pw to here, and since the value at p2 is greater than value at p1, we decrease p2 to here. Again, we compare p2 with p1, and since this value is greater, we put 5 here, and same as before, we decrease this pw to the previous one, and we decrease p2 to the previous one. And then we compare the value at p1 and p2. We can see that 3 is greater than 2, so we put 3 here, and we decrease p1 and pw here. And then we compare 2 with 2. We put 2 here, and we can choose this one or the p2. We decrease this value, we decrease this value. So now again we compare p2, the value at p2 and the value at p1, and we can see that this one is greater. We put 2 here, and that's it. We reach to end of p2 nums 2, and we don't care about the value here anymore. So that's it. Let's bring another simple example. So same as before, we put pw here, p1 here, and p2 here. So we compare the value as at p1 with p2. We found that 2 is greater than this. We put 2 here, and then we compare, we decrease the p2 to the previous one, and we can see that we don't have any, we don't have anything here since p1 is out of bound. And in this condition, we only consider the value at p2 into the nums1. So this is one edge case, and we definitely should consider the scenario that p1 is greater than or equal to 0 and p2 should equal or greater than 0. So we should consider these two. And what is the time and space complexity for this solution? Since we have 3 pointer p1, p2, and pw, in p1 we are going with we are moving from m to the 0. In p2 we are moving from n to 0, and in pw we are moving n علاوه m to the 0. So overall the time complexity is O of n plus m. And for space complexity, we have only this pointer and we don't have any extra space, so the space complexity is O of 1. So let's go to write the code for this solution. Because we set p1 as m minus 1, p2 as n minus 1, and p right as the nums1 minus 1, and then we can use a while loop. While p2 is greater than or equal to 0, we can check if p1 greater than or equal to 0 and nums1 at pointer 1 is greater than nums2 at pointer 2, we can set the value at pointer p right and set that to value at pointer p1 and decrease this value. Okay, and in the else condition, we can set nums at index right equal to nums2 at pointer 2, and then we decrease the pointer 2 by 1, and don't forget to decrease the p right in any condition. So the example that I provide nums1 as 2 and 0 and nums1 nums2 as 1 is in this scenario. So if we don't have this p1 equal or greater than 0, we are out of bound, and that is a very bad signal for you during the interview. And as we already discussed, the time and the space complexities of the time is O of n plus m, and space complexity is O of 1. Okay, so let's to run that. Yeah, it works, and it says bit 100%, but I don't know that this number is reliable or not. So that's it. Thank you.